Right. So thanks so much for joining today's class. We are going to be looking at security. Like we're going to look at everything concerning security related to FastAPI. And I will not be able to cover everything. Of course, it's totally impossible for me to cover everything. But you can always reference the FastAPI documentation. Like I explained earlier, you simply go to fastapi.tutorial/security. It explains what I'm going to explain in this class. It goes into much more detail for you. All right, so we are going to create a project again, a FastAPI project again. I did that yesterday, but I'll simply delete that and start again. Then when we are done, we'll start from there. So there's email we need to do that. Right. So I'm going to create a folder for class 10. I believe this is class 10. And just a directory. And we'll go into that directory. And we'll create a virtual environment. Then when we're done with that, we'll install the FastAPI package and start working. All right, the virtual environment has been created. So I'm going to now activate that environment. Then I will install FastAPI along with all the dependencies that we will need. Of course, we'll still install additional dependencies later on. But for now, let's start with this. So the packages have been installed. The next step is to open this project on my VS Code. So I will just type code dot. That will open that folder on my VS Code. We will okay. I'll now switch my screen to VS Code. Okay. So I'll first activate the environment here. Then I'll create our server file. Then within our server file, we are going to create, we are going to instantiate a FastAPI project, and we will attach one endpoint, just one endpoint. You know? first step, right? Then up security first step, right? Then up okay. Sync function and message. Okay, so what we're doing here right now is that I'm basically creating a FastAPI project. At line 1, we're importing FastAPI class from the FastAPI package. And at line 3, we are instantiating that class to an app. And from line 5 to 7, we are creating an endpoint that is called home. And the path parameter there is just slash, meaning is the base parameter. And this endpoint doesn't really do much. It simply returns hello world. All right. So this doesn't really do much at this point. But with this, we have the framework to start working on today's class, which is security, password hashing, and JWT tokens. So the first thing we are going to look at is password hashing. I remember yesterday I spoke about the importance of hashing passwords. All right, you know, when you have a server, let's say I build, let's say I have an app that is supposed to maybe like do something, maybe offer a particular service, and users need to register to use the app. All right. You know, this kind of apps, most of the time you need to register with your email and the password, or sometimes with your username and the password. All right. The thing is, you don't store this password as plain text. What we mean by plain text is like if the password is if the user's password is let's say like what I'm highlighting here, hello world. All right, you don't just store hello world in the database. Why? You may be wondering why. It's very risky because your database could be hacked. All right, and unauthorized party could have access to the database. All right, and if someone should like see the plain text password, it will be very easy for that person to compromise the user's account. Let's say maybe I have access to Facebook's database, and I see that maybe Uche's password is like hello world. All right, with that I'll be able to maybe copy the password, then log into Uche's account. So that's why we hash this password. What we mean by hashing is that we convert this plain text password that the user supplied into something that is totally unreadable. It doesn't really make any sense. All right, and the wonderful thing about password hashing is that it is non-reversible. It's not like encryption that is reversible. You know, when we are talking about security, we have encryption and we have hashing. For encryption, you can encrypt something, like you can convert something to a series of text, a series of bytes that doesn't really make any meaning. But you can also convert it back to what it was initially. But for hashing, it is unconvertible. It's a one-way journey. There's no going back. All right. But while it is not possible for you to reverse a hashed password back to its initial form, you can actually validate. Let's say what I mean by that is, if I convert this hello world to a hash, all right? If I convert this hello world to a hash, right? While it is not possible for me to convert that hash back to hello world, it is possible for me to validate if this hash was actually created from hello world, right? So that's basically what I mean, and we are going to look at practical examples of that in this particular class. So before we proceed with that, with the password hashing, I would love to like ask: is there any question? Is there anything you don't really understand with that before we start the actual plan?
Okay.
No question for now.
I know yesterday before the network went, you were asking a question like I was suggest what we understood by hashing.
Yes.
So if I'm correct, the hashing we are talking in this case now is it means that since the because you said it cannot be reversed when you hash a password or something, you get the hash code, it can't be reversed. So it means that anytime for a particular string of text, the hash code is the exact same, right? It's not like if you hash a particular string another time, it will form a different hash code. It's always the same hash code for any particular string of text, right? Hello?
Okay, can you
Hello?
hear me? Sorry, I
Yes, yes.
muted myself. Yeah. What I was saying is that I'm not exactly sure that we are going to look at that. So,
Okay. So I said
we'll try.
for a particular string of text, okay.
Yeah. So what I mean is we are going to maybe hash this hello word the first time, then hash it again, and then compare it to if they are basically the same.
All right.
Okay. Let me check the chat if there's any message there. And now no, there's nothing. Okay. I get it. So like I said earlier, hashing and encryption, they are two different things, right? Encryption is reversible. I can encrypt something, then reverse it back to its original form. Like hashing is not reversible, it's final. All right. So if you check the FastAPI documentation, you go to if you go to the security section, you will see the section that talks about hashing. And in Python, we have a package that is used for that. And this package is called Parsley. Right? It's called Parsley. You can search Parsley from Google, then go and look at its APIs in the documentation. But for now, we're just going to install this Parsley, and we are going to perform simple hashing operations at this point. So we are going to pick install Parsley, and Parsley depends on a hashing algorithm, right? And in this case, the recommended one, according to the FastAPI docs, is called Bcrypt, like this. So this is how you install Parsley. Okay. So with this, we have installed Parsley, and you use this Parsley to actually perform the hashing that we are talking about. So to do that, we have to import something from Parsley, and it is called crypt context. Right? You import crypt context. It is a class from Parsley, and when you do that, you then specify some arguments like the schemes, which specifies the algorithm scheme that we used for the hashing. And there's another argument which is called deprecated. You can actually go to the docs to get more information on that. So we are going to instantiate that particular class just below our. So before doing that, we are going to import the crypt context from parsley.context. From parsley.context import crypt context. Then we are going to instantiate that context with password context is equal to encrypt context. And when you do that, you need to pass in some arguments like, as you can see here, you need to pass in the scheme, and you also need to pass in another argument called deprecated. So our scheme is equal to, it will be secret, and deprecated is equal to true. So we may not have the time to look at what this deprecated really does, but I would advise you to go to the docs. So I'd advise you to go to the docs and check that out. Sorry, this deprecated is actually out, not true. All right, so we perform the hashing using this PW context, right? So the first thing I'm going to do is to create a utility function that verifies a password hash and also gets a hash from a plain text password. This is what I mean. We can create a function div hash password, which takes a plain text password, which will be of type string, and we simply need to return password context. So password context dot hash, and what do we want to hash? We simply want to hash this plain text password that was provided. So that's that. With this, we should be able to, like convert a normal string to a hash. All right. Now, the next step is to create a utility function that will take care of verifying if that hash is correct. So we'll do that with def verify hash. So verify hash will take a plain text, and it will also take the hashed password. And it will then verify the two, like it will check if the plain text and the hash match. What I mean is it will compare these two. If the plain text password that is supplied by the user is what was hashed to the hashed password, it will return true. And if it is not, it will then return false. So we do that with PW context.verify. So verify text, the first argument is the plain text and then the hash. Text this and text the hash. Oops. All right. So this function is supposed to return a bool. So let me specify the return value, which will be a bool. While the first function is supposed to return a string. So let me specify the return value to be a string. All right. Please, do you have any question at this point before we test this out?
Okay, that hashed PW, is it like where is it? Is it an inbuilt function or has it been defined somewhere? Is it a variable that you define? Because I'm not seeing where you defined it. Is it like an inbuilt function? That hashed PW. Or
So you're referring to line 11, right?
Yes, line 11, yes.
You're referring to this, right? Okay. So it is an argument. Like when we call this verify hash function, we are going to pass in this argument, right? The plain text password that we want to verify, and then the hashed copy that you want to verify. Then
Okay.
we are actually comparing the arguments that we pass. It's not an inbuilt function.
Okay.
Right. So please, do you have any other question before we proceed?
Yes, sir. I have a question.
Okay.
The plain text password, that plain text is actually the password that we inputted or that we converted to the hashed password, right?
Yes.
So that means, is it that if that means will the password now, will it be stored in plain text before it is being hashed? Or this one is just an example?
No, how this works is that, take for example, during user registration, you have an app that users need to register. All right. So while users are registering, you submit your information like your email, your password, your first name, blah blah blah. So when this information comes to the backend, all right, you take that plain text password, then call this function, this hash password function. All right. So you call this function and then pass in that plain text password to the function. Then this function will return the hash of that password. Now, you don't store the plain text password in the database. Like, you don't do anything. You just use it to get the hash. It is the hash that you store in the database. Then you discard the plain text. So this verify hash is utilized at login. When the user wants to log in, when you're logging into, let's say, your Facebook, you submit your password, the password you used to create the account. So now you get this password that the user submitted, which is plain text. Then you call verify hash. All right, you pass in that plain text, and then you pass in the hash, this hash that you have saved earlier. You extract it and then pass it there too. Then the utility function will then compare the two. If they match, right, it will tell you, okay, this is a valid credential. And if they don't match, it will tell you that it is wrong. Then you can either reject the login attempt or you approve the login attempt at that point. Please, have I answered your question or?
Yes, sir. Yes.
Yeah, I understand too. I wanted to point something out, but it seems, I guess the code will still run. On that line 11 and 12, you wrote plain text instead of plain. There's no L. So I don't know if that was intentional.
No, that was a mistake. The code was still run. Okay. It was a spelling error. Thank you. All right, so we are going to actually test this. We'll create an endpoint, a simple endpoint that receives a plain text, right? Plain text password, and returns this thing. It returns the hash for which is on the front end. So maybe let me do it here at home. So we are going to import space model from Kode. Then we are going to create a schema. And I want the user to supply only the password. All right, so maybe let us use this home view instead of creating a view. So that will be of type this password schema. All right, perfect. So I want to actually return. Okay, first let us hash the password. Hash is equal to, let's say, PW hash is equal to. We'll then utilize this function that we created earlier. This hash password. Then we'll pass in the plain text. And okay, simply what I'm doing. So there's no need to use keyword again. So I'll simply pass in the data that the user supplied. Yes, so that is it. Now, instead of returning just hello world, I want to return the hash. Okay, I want to return plain text, which will be the password the user supplied, password. Then I want to return hash, which will be the password hash that we have generated. Okay, please, do you guys understand what I'm doing here? Is any question on this before we test it out?
Yes, I understand what you have done so far.
Okay. So what I'm basically doing is I'm creating an endpoint that accepts data from the front end. All right, it accepts a password string from the front end, and it gets this password string. That's this plain text password. Then it computes the hash of that password, and it returns both the plain text and the hash. Right. So let us test this out and see if we are doing the right thing. KodeCamp server up. Okay. Now let me start my Zoom and let us see. Oh, I made one mistake here. I remember I told you in the first class that when you are sending data to the server, you shouldn't use a GET request. So please let's update that first. So when you're sending data to the server, try to use a POST request or PUT request, not GET.
Okay, I was also suggesting the other day, maybe if you could check, there's a VS Code extension called the Thunder Client, or maybe.
Oh, yeah. He told me that.
Yeah.
Sorry, I forgot.
No.
I'll look into it today at the end of the class.
Okay, no problem.
Yeah, I think it will help us. So we're going to send this request to the back end and we'll see what happens. So it accepts a password string, which should be, let me say hello world. Listen. Good. So can you see what we have on the screen?
Yes.
Yes, we have the hello world is equal to this. So please take note of it. Let us send the request again and see if it will be the same hash. Okay, it's different.
It's not the same thing.
Yes, it's not the same. It's not the same. But we should
The same hash.
Can you hear me?
Yes, I hear you.
Okay. So it's not the same. They are different. So you can see they are different. But we should be able to verify this. Let me put another endpoint that helps us verify this. Our code is very fine.
We're not seeing the VS Code.
Okay. I forgotten that. Okay. So I'm trying to create a new endpoint that will receive the hash and the password, and then it will confirm that the hash and the password match. So let us see. Let's create a new schema for verify. Okay, do you know, maybe instead of receiving both the hash and the password from the front end, let's do something different. Let's do something different. Let me store the hash that was generated, all right, on a variable here on my back end. You know, it is not normal for the hash to come from the front end, all right? So I'm trying to replicate that. Let me copy this hash we generated and I'll keep it. And I'll just send the hello world again. So I want this to return I want this to check if it is valid or not, then return the data for us. So what this endpoint will do is it will take the password that is sent from the front end from our clients, then it will compare it with what we have here, and then we'll check whether they are the same or not. So let us say is valid is equal to, I'll call the verify hash function here. Verify hash, and verify hash takes the plain text and the hashed password. All right. Now the plain text will be sent to us from our clients. So that will be data.password. Then the hashed password is this password that I have copied and pasted here. Now let us see if we are going to get through. Okay, I hope you understand what I'm doing here. Any question on this?
I think I understand. We just took the normal hash, the hash that has already been generated and put it, and you call the invalid function, you put the hash, the plain text password and the hash password, and we have already defined the verify hash function to return a bool. So it will either be true or false.
Yes. So that's just it. We are trying to mimic a situation in which the user created an account initially, and we hashed the password and stored it in a database. Right. So that's why we have this password hash. Let's assume that it's extracting this hash from our database. All right. So now we want to validate that. We want to test the verify hash. All right. If we supply the plain text that we use to generate this hash, then compare it with this hash, we know whether they are the same or not. So that's what we are trying to do here. Let's check. It should return either true or false. Verify. So let's see.
I'm still seeing the VS Code.
Oh. Sorry about that. Insomnia. Okay, I'm getting null. Let me check why it is null. There could be a mistake somewhere. Verify hash. Password hash. Verify hash. Text password. Then return value. Okay, let me check again. Okay, we are still getting null. I'm trying to check why it is null.
Okay, let's see the VS Code. Let's see if we can also.
Okay. Okay. Oh. Sorry. Can you see this verify hash function? I didn't return anything. Can you see that?
Okay, yes.
Yes. I didn't return anything. It was just PW context of verified, which is not right. So let's restart the server and try that out. Okay, let's check. Ooh, so we have true. Now let us confirm that this is not a false positive. Let me add something to this password, and then see if we get false. Yes, we have false. Right? We have false. That means if the user should enter something that is not the hash, all right, it will always give yourself a false. So you can then implement another check. Let me switch back to my VS Code. So in this kind of situations, you can, for example, let's assume this was login. You can then implement a check that if is valid, maybe you perform login, okay, or you validate login, then else maybe raise an exception, right? Let me just comment that. You maybe raise an exception. For now, let me just pause to avoid that error. If is valid, do something. Okay, this one passing. Then else do something. All right, do you understand what we have here? Is any question on this?
Yeah, I understand.
I have a question, sir.
Correct. Please, what's your question?
Not as regards the logic though, but during the hashing of the password, the hash number was changing. So
yes.
Because I've worked on what's it called with normal Web3 of a thing. So I've seen how they used to hash their password. Like once you enter or a variable whatsoever, it's always giving you the same password or the same hash number. Do you get? So I don't know what this one is changing because I believe since it's the same name, it should give you the same hash password.
Okay. As for why it is changing, I've actually not looked at the password source code. Maybe it's probably due to. Let us switch to.
Okay, I have a suggestion.
Okay,
I think it is because of the password encryption this thing algorithm used, which is this bcrypt. I don't know bcrypt. I guess the one that he's talking about is maybe SHA-1. I know that SHA-1 algorithm does not change.
I think that is SHA-254.
Okay, SHA-254. Okay,
256 or 254.
Yes, 254. It doesn't change.
It's probably due to the algorithm they are using and the code. Like, can you see my screen?
Yes.
Yeah, so this is a pass slip. This is a pass slip report on GitHub. I've actually not looked at the code. I've actually not taken a closer look at the code. So it's probably due to the algorithm, yes. Which is right. It's probably due to the algorithm. But I cannot be 100% sure because I've not looked at the code. But the thing is, the main thing is that the hash changes. All right. If you are creating a hash with hello world, you created it the first time and then you created it another time, they will not be the same. They will change it. But despite the changes, it will be possible for you to verify. Like if you copy the first hash and you replace it here with the password hash, it will still verify whether it's true or false and all of that. So that's just it with hash. Do you have any other question before we move to JWT token?
No question from my end.
Okay. All right. So now that we are done with password hashing and the verification of the password hash, the next thing is when you're building APIs, right, we normally use token authentication. What this basically means is that when the user logs in, for example, at this verify endpoint, you verify the credentials. If they are correct, what you send back is a JWT token. That's a JSON token. And it is this JSON token that the user will use to authenticate itself, like for every other request that he or she is making. I think the right word here would be maybe the client, not the user, right? Because the user doesn't really know what's happening under the hood. So you return this JSON token to the client, and the client will then attach this token to the requests. Every single we actually handle authentication. Yeah. So I'm going to modify this code base, and we're going to introduce this JSON tokens. We'll look at how these tokens can be created, how these tokens can be encoded, and how you verify these tokens from the server that they are actually correct. I hope, yeah, my battery should let me complete that. So let me change this to verify. Now let's install something else to actually work with tokens. We have another Python package that we use for that, and it is called Jose. All right, it is called Jose. You can, let me switch back to my browser. To read more about it, you can always go to their documentation or their GitHub repository. Just GitHub. Just implementation in Python. Yes. Or maybe we can search quick. Okay. All right. So this is the documentation. Okay, the documentation is just read it also. JDQ, import Jose, signature, serialize comfort, okay, so when you are free, right, on your free time, you can come to Jose or read the docs.io /en/latest to get more information on the different APIs available for this particular package. All right, we will not have the time to look at this in depth. Right, we are going to use it to we're going to use this to create a simple JWT token and also decode that token. Right, so to do that, we're going to pip install Jose. We are going to install Jose with pip install Python Jose, and it also takes a it also takes a backend that is called cryptography. That's the algorithm that is used for the actual encryption and all of that. So can you see my terminal?
Yes.
Okay, so it's pip install Python-Jose. We have square brackets. Within those square brackets, we have cryptography. So we'll install that. Okay, so we are done. We are done installing it. Now we are going to import the package JWT from Jose, and that's what we'll be using to perform the JWT encoding. So from Jose, import JWT, and we'll also import JWT error. The JWT error is for situations in which maybe the client is sending a wrong token and the encoding fails or the decoding fails. All right. In that situation, that JWT error will, like, you use it as a try catch. Right. That will then catch the error. From there, you can do something with that one. So to actually work with this, Jose, we need some things. We need the secret key, we need the algorithm, and also we need an expiration. This is what I mean. We need a secret key. That's the secret key that we'll use for the sign. Then we need an algorithm. What kind of algorithm will we use? We're going to use this HS256. Okay, let me use this an empty string for now. Then we're also going to specify the expiration, access token expire minute. For now, let's say it should expire after 90 minutes. Right? So to save time, I'll just copy and paste this function, then I'll explain it. That's to save time, So, all right, so what I want to do here is I want to create a function that will help us create the JWT. And this JWT, you create it from a data, like maybe any data you want to include. So that's why our function here takes a data parameter, like whatever data you want to use for encoding. And I want this data to be of this structure.
Sorry, I can't hear your audio. I don't know if it's just me.
Same here. I don't know what's happened.
Still nothing. I can't hear your audio. Still nothing. I can see your screen, but I can't hear. Still nothing. Nothing at all, just silence. Can't hear. Maybe possibly disconnect and connect again. Still not. No, we can't hear you at all. Nothing. MJ, Mikey, can you hear him? I can't hear him. I can't hear anyone. Nothing. Silence.
I can't hear him. I can hear you.
Okay.
I can't hear him.
Okay, can you hear me?
Yes, we can hear you now. Yes.
Yes, you can hear you now.
Okay. Let me share my screen with my laptop. Okay, so you can still see my screen, right?
Yes.
Yes, you can see the screen.
Okay. So we'll continue from here. So we wanted to create an endpoint that will help us encode whatever data we want to pass into that we want to convert to a JWT token. All right. Then we'll also create a separate endpoint that will decode this data back to what we passed into it. So first, I just want to. So first, I want to encode the email. I want to encode an email. Then I will also specify the expire. Like this token should expire at what point? That should be optional. I want this to be an optional date time. All right. All right, so we have that. So this create JWT will take a data that will be of type this. For now, it should do nothing, just pass. Then let me create an endpoint that will make use of that. So I want this endpoint to accept an email only. Then this endpoint should simply return data JWT, and this JWT will simply be JWT is equal to, I'll call this function create JWT, and then pass in the data. Data JWT schema email is equal to data dot email. Sorry. Use JWT data instead. Then let this data be JWT data. So sorry, do you really understand what I'm doing here?
I will need to there are some parts that I'm not, maybe you just quickly go through everything again after you run the code, after you type the code.
Yes, I will do that. So I'm trying to rush, I'm trying to rush this down because my battery is getting low. So I'll do some copy and paste. Then we'll explain later. So okay, what I'm doing here is that, can you see this create JWT function? All right, this function is the function that is supposed to encode any data we want to convert to a JWT token. All right, so it takes in the data, and this data will be of type this JSON schema. This JWT schema, it will contain an email. All right, then it can optionally contain an expire, but I don't think we are going to use it now. So let me just do that. Not necessary. Let's do that. All right, so it will just take this data, then it will encode, it will call JWT.encode. This JWT is the JWT that we imported here up. Can I see this from Jose import JWT? That's the JWT we imported there. Then it will then call the encode function. All right. If you read what we have here, it encodes a claim set and returns a JWT string. Like whatever data you pass to it, it encodes it and then returns a JWT string. So we encode the data. Then this encode also takes a secret key. All right. For now, we are using an empty string, but I'll change that soon. It takes a secret key, then it takes an algorithm as well. And right now, we are going to use this algorithm HAS256. All right, so when you do that, it will create an encoded string. So we are going to return that encoded JWT. All right.
You've not put return in front of it.
Oh, sorry about that. Okay. I don't want to encode a pedantic model. So let me convert this pedantic model to a standard Python date. So into data date, it's equal to data.date. So that's line 52 simply converts this pedantic model we have here, that's data that we have here, into a dictionary. So we want to encode that dictionary instead. All right, so with this, we should be able to encode that data. Now let me create, let me get a secret key for us. You can do that with your command line. To create a secret key with your command line, you run this command OpenSSL rand-x, OpenSSL rand-x. Then you also specify the bytes, that's 32. So this generates the 2-byte string for us. We can then copy that and use that as a secret key. So with that, when we get an email from this endpoint, it will then encode that to a JSON token, and then it will return that JSON token for us. Now let's try this. Okay. Let me convert this. Okay, we are switching to a Postman right now. Email, I'll use hello@hello.com. So let's send that to the JWT endpoint and see what happens. Good. Can you see what we have here?
Yes.
Yes. So it has it has encoded this data that we've sent to read, and it has given us back the string. So now to demonstrate the decoding, I think that's what we'll be able to do for the class today. To demonstrate the decoding, we will try to convert this string that we have here, back to what we had earlier. That's back to the email that we used to generate this. To do that, let me create a new utility function that we can use to decode the email. Sorry, who is that? All right, sorry about that. So I'm trying to create a new endpoint that will handle the decoding of whatever token is passed to us. So I'll do a little bit of copy and paste here to save time. All right, so can you all see my screen? Can you hear me?
Yes, I can see it.
Okay, so
Yes, you can.
okay. So we are creating a function that accepts a token. All right, then it will then decode that token. We'll use the secret key, the same key that we use to encode it. We use that same key to decode it. And algorithm, I want it to still use the same algorithm that we used. Good. So with this, we can then return the payload. Payload. Now I want to, let's use the same endpoint at first and see what happens. Payload is equal to decode the JWT. Then it passes in this same JWT that we created before. And now I just want to return the payload. Let us see. Payload. Okay. I think let me explain this again before we actually test it out. So just like we have JWT.encode, all right, we use this to actually encode data to a token. We also have JWT.decode, like we use this to reverse what we encoded. All right, do you understand that?
Yes, I understand.
Yeah.
Okay, JWT.encode to encode, then JWT.decode to decode, and they basically accept the same data. All right, to encode, you pass in the data that you wanted to encode to that JWT to the token. All right, then it accepts the secret key and an algorithm, and the same thing with decode. You pass in the token that you want to decode, then the secret key and the algorithm as well. So now let's test this out and see if it works. Sorry for rushing. My battery is critically low. I'm trying to.
Yeah, no problem.
I'm trying to cover this up so that we're done. Okay, so let us see this. All right. So can you see what we have on the screen?
Yes, I can see it.
Yes, we encoded email hello world. All right. Then when you encode this, it gave us this JWT. Then at the back end, we also decoded that particular JWT to get the data we had earlier, which still gives us the hello at hello.com. If this is something else, like maybe blah, 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 this thing, and we send this, it will do the same thing. It will like encode and decode. Like why are we doing this? Why we are doing this is because this gives you an avenue to, like, when you want to authenticate the user, all right, the user submits his or her details, all right, you take these details. First, you take the authentication credentials, then verify these credentials if they are correct. And if these credentials are correct, you then encode this user's data. For example, an identifier, like how do you identify this user in your database? Most times it is the email that the user signed up with or the username that the user signed up with. So you encode that. Another thing that you encode is the expiration. Like, what time do you want this token to expire? All right, you encode that as well. Then you sign this with your secret key. All right, that means no one can decode this token without the correct secret key. So that means that token is secure. No one else can decode it. Like, that will keep the token secure. So when you send this to the user will then attach this token to every single request that the user makes to your backend server. Then when you get this token, you decode this token on your backend and then check if the data you're passing are the kind of data you're expecting. The first thing you check for is the email. Like, do we have this email in your database? If the email exists in your database, you say, okay, that's perfect. Then you also check the expiration. All right, this expire time is the current time farther than expired time or lower than expired time. All right. Then if it is farther than expired time, it means that the token is still active. All right. But okay, no. If it is farther than the expired time, it means that the token has expired. For example, if I specify that the expired time will be maybe today by 12 p.m. All right. And the user is supplying this token at about 12 p.m. Okay, at about 1 p.m. I can then decode this token, take the expired time, and then check is the current time more than the expired time or less than the expired time. If the current time is more than the expired time, it means that that token has expired. I'll just reject it. Then if the token has not expired, I'll then go ahead and then validate the token and do whatever I want to do with the token, identify the user and all of that. So please, do you have any question on that for now?
Okay, let me, if I'm correct, the essence of that expired time, is it like ideally in a real world situation, is it because, for example, I know like if you are maybe creating an account on a website, usually they'll send something like a kind of OTP or a kind of confirmation link to your email where they'll say, okay, go to your email, click this link to confirm your registration. And then if you don't click the link between maybe some hours, is it the same concept here?
No. That one is very different. That one is very, very different. Sorry, my laptop is down, so we cannot, I can't share screen anymore, but we can still talk here for the next few minutes. So that particular situation is different. Let's say a user signs up on my server and I need the user to like maybe activate the account, or maybe a user wants to reset his or her password. All right. In that case, we don't use OTP. We generate a one-time token at the back end. Let's say I can generate a 4-digit token, then store this token on my database or maybe my Redis database. All right. Then set the expiration on. If you are using Redis, it is possible for you to set the expiration of whatever data you store there. You can specify that, hey, I want this data to expire after 3 hours. What that means is after 3 hours, that data will be deleted from that Redis database. All right. So when you send this token to the user will then will be in charge of like entering this token at where he or she is supposed to enter this token to actually reset the password. And when this token comes in, you go back to your database and check if this token exists. All right. If this token actually exists, and the user that is attached to the token is the user making the request, you can then approve the password reset. But if this token does not exist for any reason, maybe the user may have entered the wrong token, or maybe this token has expired, at that point, you can then safely reject the password reset request and notify the user that, hey, this particular token you entered is incorrect, or your token has expired, or any other.
Okay, I understand.
Okay, so the case for this JW2 is mostly for authentication, like it's used to identify the user. All right, it won't really make sense to maybe store the user credentials, that's the user the username and the password on the client side. All right, so most of the times, like I had explained earlier, we'll prompt the user to like log in with his normal credentials. What I mean is the username or the email and password. All right. So when you have validated these credentials as correct, you then create this JWT token. All right. You encode it with the user identifier, like whatever you are using to identify the user on your back end. It could be the username. Usernames are usually unique, or the user email. These are usually unique. So it is a valid identifier. You can then encode that identifier and the expiration. All right. I didn't have enough power to actually work on that expiration, but hopefully in the next class we'll do that before we move to next class topic. So you then encode like an identifier and the expiration. All right. Then send this, package this, and return it to the front end. All right. Now, the client will be in charge of attaching this token to every single request he or she is making to the backend. All right. Now, when the request comes to the backend, you then extract this token and then decode this token. You decode this token with your secret key. if for some reason it fails, all right, there could be numerous reasons for that. It could be that maybe the token is invalid, or maybe the token was encoded with a different secret key. In that case, it will fail because it must always be with the same secret key that used to encode the token. So that's just it. If you successfully decoded the token, that means it was encoded with your secret key. Then you can then extract the data that you encoded. For example, the user identifier, you check the database, does this identifier exist? If it exists, you then extract the user, all right, and then work with that.
Okay. So that is okay, if I'm correct. So that means it's more like just like you say, authentication. So it's like another way to put it is like maybe you want to know that okay, this user maybe has access to maybe a particular information. So maybe this client, this user is trying to maybe make a request on a particular data or a query or something, and then that this JWT is a form of authenticating that okay, this user maybe has access to this particular information that is trying to request.
Yes, perfectly. A very good example is okay, let's say like yesterday at my workplace, we were working on a feature that's we wanted to create an endpoint that helps user to update a specific information on that particular user on the server. All right. The thing is, when you are like creating this endpoint, you create like a generic endpoint. All right. We don't create one endpoint for one user, the next endpoint for the next user, the next endpoint for the next user. It would be impossible to manage. All right. So you create one endpoint. Now, when the user wants to perform this operation, the user needs to attach its token, the user token that you had generated for him or her. And it is with this token that you use to identify the user that is making this request, extract this user account from the database, and then make the operation, like maybe update the data that you needed to update for that specific user. So that will make it totally impossible for, okay, I wouldn't say totally impossible. That will make it very, very difficult for someone, maybe for me, like updating your own data, all right? That will make it very difficult because I don't have access to your token, all right? I can only do that if I have access to your token. So to further clarify that, the token is basically used for identification and authorization in the backend.
Okay, I understand fully now. I understand.
Okay, sir. I have a question.
Okay,
two
please.
actually.
Right.
Yeah. The first one is the algorithm. How do you just decide whatever? Because I saw a string with some letters there. Is it unique or you just specified yourself?
Okay. It's actually in their documentation. All right. I think Jose, if you go to their documentation, they have a list of algorithms that they support. All right. So you just use any one of them that you wish to. But
all right.
Yes, but on the FastAPI documentation, it's recommended that you use the HS256. So I believe that should be the most secure of the three.
All right. So I also saw the JWT schema. You kind of wrote it 2 times. I don't know if there was any reason for that.
Okay, my system is down now, so I can't really check to verify.
Yes, I was hoping you would be able to see that, but you wrote it twice when you were writing the 2 different.
Yeah, I noticed that the first one you put email and you put there were 2
yeah, he put the second one, he put the expiry.
Yeah,
okay.
yes.
I think I recall now. So the first one that contained the email and the expiry, that one was for like the schema of the JWT token, all right? Like the kind of data that we want to encode to the JWT token. That was for the first one. I think while the second one was the data that will accept to that endpoint.
Yeah, they were exactly the same, like the naming.
Okay.
Exactly
They were the same. Yeah, it must have been a mistake. Yes, it must have been a mistake. And my system is down. I would have rectified that. So what I'm going to do is I will power up the system within the next few minutes, and when I'm done, I will go back to the code. Then I will clean up that code. I'll clean up that code. Then I'll add a lot of comments to it. Then so that it will be easier for you to follow through what we did. Then before the end of the day, I'll push it over to our class repository so that you can pull it and go through it. And if you have any question, any suggestion, you can let me know. You can let me know, and I'll do my best to explain it more. Or we can always get on a call on Slack. And that's it.
All right, sir.
All right.
Thank you very much.
All right, sir. Thank you. Thank you very much.
Okay. All right. Thanks a lot. Thanks a lot. So with this, we've come to the end of the class for today. And the next class will be next Thursday. And I think, let me confirm the topic for next class for you. Please give me a minute. Okay, in the next class, we'll be looking at background tasks and testing. Can you hear me?
Okay. Yes.
Yeah, background task and testing. And so far we've been testing manually. All right, we've been testing manually, which is very, very, it's not as how do I even put it? It's not really the right approach. Why I'm saying so is because let's say you are building a project, you are building a server that has a whole lot of endpoints, maybe like 300 endpoints or so. Okay, it always helps to include in the test because number one, there could be changes in the dependencies you are using. So when you upgrade a particular dependency, how are you sure that your whole code works, right? But if you have unit tests, whenever you make changes, whenever you refactor the code, whenever you update your dependencies, the libraries you are using, you can always run this test again. You can always run this test again, and it will then, within a few minutes, it will test everything and check if they are working as expected. And if they are not working as expected, it will then point you to the right direction. Okay, this particular endpoint is not working as it is supposed to do, as it is supposed to work. This particular function is not working as it is supposed to work. So that's why tests are useful. And though they are slow to write, it's always best to really understand how the whole thing works and appreciate the importance of writing the test in the first place. So that's what we'll be doing in the next class. But maybe in that next class, so I will look at some things related to security as well. I'll do my best to round up some of the things that we may have missed in today's class. We'll look at it then again in the next class. Then we will then write the test for these things so that we can kill two birds with one stone. All right, so I guess that'll be all for today. Thanks so much for attending the class. We really appreciate it.
Thank you very much, sir.
Thank you, sir.
Don't forget to check that client, that Thunder client.
Yes. I'll look it up tonight. Thank you.
All right.
Yes, sir.